Okay, this is a review for the homework that we have. And so we're looking at operations with linear functions. And so we've already done numbers 1, number 2. I'm going to do number 3, 4, 5, and 6. I'm going to start with number 3. And in number 3, it says, if the function of x is equal to negative 3x plus 15, and g of x is equal to negative 4x minus 17, they want us to find the difference of the function of x and the g of x. So I'm going to start by writing what it is that they want us to find, which is the function of x, or f of x, minus g of x. And what I have been given is that f of x is equal to negative 3x plus 15, and g of x is equal to negative 4x minus 17. So now the very first step is to substitute. So I'm going to substitute in for f of x, I'm going to substitute negative 3x plus 5. And in place of g of x, I'm going to substitute in negative 4x minus 17. The substitution property says that if a equals b, then b can replace a. So if the function of x is equal to negative 3x plus 15, negative 3x plus 15 can replace f of x. So I'm going to plug it in, and I'm going to skip lines here just so that it's nice and neat. So in place of f of x, I'm going to put negative 3x plus 15. I'm going to put that in parentheses because I'm substituting it in. Minus g of x. And g of x, also in parentheses, I'm going to put negative 4x minus 17. Now, there are a few mistakes that we make here. We see minus and negative, and so we tend to apply the negative here by changing this sign, but we forget to also change the sign of the second term. So what is really here, the imaginary coefficient in front of this variable term is, or not variable term, but in front of this parenthesis, is going to be a 1. So what I want to do is I really want to distribute negative 1 to both terms, and then I'm going to combine like terms and simplify. So I'm just going to bring this down, which is negative 3x plus 15. I'm going to just leave it in parentheses. I don't have to, but I'm going to because I don't want to do anything with it yet. And I'm going to distribute this negative 1 to negative 4x, and then distribute the negative 1 also to the negative 17. Now, normally we write out negative 1 times negative 4x and then negative 1 times negative 17. But I want to kind of transition you to doing that mental math. So negative 1 times negative 4x, and negative times a negative is going to give us a positive 4x. And then negative 1 times negative 17, and negative times a negative is a positive 17. So now I'm going to bring these two terms out of the parentheses because they are already simplified. They cannot be combined. There are no like terms there. So I'm going to pull them out, and I'm going to bring everything else down as is. All right, so now I have some like terms. This is not simplified because I have like terms. And the like terms that I have are negative 3x and positive 4x. So I want to combine those. I'm going to put them together, and I'm going to use commutative property to rewrite the things that are like terms and put them side by side. So I'm going to rewrite this expression as negative 3x. This is a positive 4x. The sign in front of the number comes with the number. I'm going to pay close attention to my structure so that everything is lined up. And then I have 15 and positive 17, so positive 15 and positive 17. So now I'm ready to combine my like terms. I have negative 3x and positive 4x. You have negative 3, you move to the right 4 units, you'll end up at positive 1. Or you can see that as 3 negatives, and then you have 4 positives. You're going to end up with 3 zero pairs, and that's going to leave you with 1 positive. So this is going to be positive 1x. And then here I can combine these two, positive 15 and positive 17 is going to give me a positive 32. I cannot combine these two. They are not like terms. This is a variable term, and this is a constant. So simplify, it is 1x plus 30. All right, so I'm going to move on now, and I'm going to do the next number, which is number 4. So for number 4, they are asking us to find h of x. And so I want to look at what I've been given. If I look at this sheet, I'm asked to find h of x. And if I look at what I've been given, h of x is equal to g of x minus f of x. H of x is equal to g of x minus f of x. And so if I take f of x, which is 4x minus 29, I'm sorry, if I take g of x, which is 2x minus 18, and I subtract f of x, which is 4x minus 29, then I will find h of x. So let's go ahead and substitute in. So we want to find h of x, and we know that that is equal to, according to what we've been given, g of x minus f of x. Now, what do I know? I know that g of x is equal to 2x minus 18, and I know that f of x is equal to 4x minus 29. So I'm going to substitute in what I know. So h of x, again, I'm skipping lines, but I'm going to leave all of my terms lined up. G of x is going to be 2x minus 18, so I'm going to replace g of x with 2x minus 18. I'm going to put that in parentheses, 2x minus 18, minus, what am I subtracting? The whole f of x, which is 4x minus 29. Now, like we spoke about before, there's an imaginary coefficient in front of this parenthesis, and so I'm going to go ahead and put that in there. And what that's telling me to do is that I need to distribute the -1 to both terms in the second parenthesis, or I can change the sign. It's going to do the same thing because multiplying by -1 changes the sign of the number. So I'm going to have h of x is equal to 2x minus 18. And now I'm going to apply this -1 by multiplying. Negative times a positive is a negative. -1 times 4x is negative 4x. A negative times a negative is a positive. A -1 times negative 29 is a positive 29. So now I can't do anything more with this because it's simplified already. So I'm going to pull that out of that parenthesis. And I'm going to have h of x is equal to, remember we're solving for h of x. Our question asks us to find h of x, which is g of x minus f of x, so we're subtracting the two. So I'm going to pull this out, 2x minus 18 minus 4x plus 29. And now I see that I have some like terms that I can combine. I have 2x and negative 4x. I have negative 18 and I have positive 29. So I want to put my like terms side by side. So I'm going to use the commutative property. Being mindful to keep my structure aligned, I'm going to line up my h of x, and I'm going to rewrite this with my like terms side by side, putting my variable terms first. So I have a positive 2x, and I'm going to put that with a negative 4x, and then I have a negative 18, and I'm going to combine that with a positive 29. So now I have h of x is equal to 2x minus 4x. You can't take 4 from 2. So you're going to end up with a negative, and so we're going to have negative 2x. Please do not forget to carry your x. Do not drop it. Another way to look at that is if I have 2 positives, but I have 1, 2, 3, 4 negatives. These are going to cancel out, and that's going to leave me with 2 negatives. Another way we can look at that is if we had a number line, and we're starting at positive 2, and we would go to the left 4. Left 4. Start at 2, go left 4. So I'm starting at 2, and I'm going to go left 1, 2, 3, 4. Where would I end up? If this is a 2, and I'm going to the left, then the numbers get smaller. So that's a 1, a 0, a -1, a -2. So we would end up at -2 on our number line if we started at 2 and went to the left 4 units. So what do I have here? -2x. Now, let's think of it again. I have 18 negatives, and 29 positives. So if I have 18 negatives and 29 positives, then I have more positives than negatives. I'm going to end up with 18 zero pairs, and that's going to leave me with a positive 11. Another way that I can look at that, because commutative property says that A plus B is equal to B plus A. So if I have negative 18 plus 29, that is the same thing as 29 plus negative 18, or 29 minus 18, which still gives me 11. So negative 18 plus 29 is 11. So now my final line is going to be, well, there's nothing else to do. So this is actually my final line. My final line, because I cannot combine these two, is going to be h of x is equal to negative 2x plus 11. All right, that's number 4. Now let's look at number 5. All right, so as I look at number 5, it's asking me to find k of x. And if I look at my sheet here, k of x is equal to f of x minus g of x this time. So we're going to take f of x, and we're going to subtract g of x from it. So I'm going to write that out. K of x is going to be equal to f of x minus g of x. F of x, g of x, O-F of. All right. And now I'm going to go ahead and write down what I've been given. So I know that f of x is equal to 4x minus 29. And I know that g of x is equal to 2x minus 18. So I am going to plug these in. So k of x is equal to, remember, structure is very important. We want to keep everything lined up nice and neat. In place of f of x, k of x equal f of x. What is f of x? 4x minus 29. Make sure that your signs, as you carry the right signs over for your problem, I'm going to put that in parentheses. I have minus, minus. Now, my g of x is 2x minus 18. I'm going to put that in parentheses. And now, again, I'm subtracting the second term, or the second parentheses. So I'm going to put an imaginary coefficient of 1 there, which means I want to distribute a negative 1. So I'm going to have k of x is equal to, I'm going to leave this in parentheses because I just feel better with it nice and secure in there. But I'm going to distribute this negative 1. So negative 1 times 2x. A negative times a positive is a negative. And 1 times 2x is 2x. And take your time, one step at a time. Negative 1. Don't forget to distribute to the second term. Negative times a negative is a positive. And 1 times 18 is 18. So now I want to pull this out of this parenthesis because there's nothing else to do with it. So 4x minus 29, and I'm going to bring down what I just, the result I just got by distributing the negative 1. And so now I have 4x minus 29 minus 2x plus 18. Well, again, I see like terms. This is not simplified because I do have like terms. And simplified means no like terms, no parentheses. And I actually have like terms, so it's not simplified. So I want to combine those like terms, but I'm going to use the commutative property to put those things that are like side by side. Remember, like terms are terms with the same variable and the same exponent. So I have 4x and negative 2x that are like. So I'm going to rewrite this as k of x is equal to 4x. And then this 2x has a minus in front of it, but if I read the term itself, it's a negative 2x. I'm going to put negative 2x. I'm keeping my terms lined up, first term, second term. So now I have a 29, but I'm not going to put a positive 29. I'm going to put a negative 29 because this 29 has a minus in front of it. So if I read that term by itself, it's a negative 29. And I'm going to put that with the positive 18. So now we have k of x is equal to 4 minus 2. Well, 4 take away 2 is 2. So 4x minus 2x is x. Don't forget that variable. Let's be precise. Let's make sure that we carry all parts of that term. So now I got negative 29 and positive 18. So I have 29 negatives and 18 positives. 29 negatives and 18 positives. So if we have 29 negatives and 18 positives, we're going to end up with 18 zero pairs. But I got more negatives than positives, so what am I going to have left over is 11 negatives. So I'm going to put minus 11, and I'm done. Because 2x minus 11 is already simplified. You can't simplify it any further. So this is going to be my answer. K of x is equal to 2x minus 11. We just simplified that expression. All right, so the last one that I am going to do is going to be number 6. All right, so for number 6, or maybe I'll do number 7. For number 6, we are asked to find f of x times g of x. So we're no longer adding or subtracting, we're now multiplying. So they want us to multiply these two. So we're going to follow the same steps we would follow any other time. First, I got to know what f of x is and what g of x is. So off to the side, I'm going to write what I've been given, which is that f of x is equal to 3, the constant 3, and g of x is equal to 2x minus 17. Pretty simple. We're just going to plug these numbers in. So if I plug them in place of f of x, I'm going to put 3. I'm going to put it in parentheses as I would anything else. Times, 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 times. And for g of x, I'm going to put in parentheses 2x minus 17. Now, this may look a little strange because we're not used to seeing that dot in the middle, but it does mean multiplication. And remember, multiplication can be written several ways. It can be written with a decimal, not a decimal, a point in the middle. So that's 3 times, just like this, 2x minus 17. Or it can be written where both of these are in parentheses side by side. Or either of these, this can come out of parentheses so that we can just multiply this number by this factor by this factor. And so I want to put it in a structure that I'm familiar with. So I'm going to pull this 3 out, and I'm going to put 3. And next to that, in parentheses, leaving this in parentheses, I'm going to put 2x minus 17. Now, this is still saying the same thing. This is f of x times g of x, f of x times g of x. It is still f of x times g of x. A number next to a parenthesis means multiply. So what does this look like? This looks like distributive property. So let's use distributive property in order to simplify this expression. So I'm going to multiply 3 times 2x, positive 3 times 2x, and then I'm going to multiply positive 2 times negative 17. You have to remember to distribute that. I'm sorry, I'm saying 2, but it's 3. Positive 3 times 2x, and then positive 3 times negative 17. And we have to make sure that we distribute that 3 to both terms. So I'm going to do mental math and think to myself, a positive times a positive is a positive. 3 times 2 is 6x. 3 times 2 is 6. 3 times 2x is 6x. And then 3 times negative 17. So a positive times a negative is a negative. Notice where I'm getting my signs from. I'm not putting this negative here just because it's there. I'm putting this negative here because a positive times a negative is a negative. I can't just pull this. Because if this would have been a negative 3, then a negative times a negative would have given us a positive, and so this would have been a plus sign. So don't pull the sign that is there. In your mind, go through and see what is that sign going to be after you find the product. So positive times a negative is a negative, and so 3 times 17 is going to be 51. And so I'm done. 6x minus 51 is this expression simplified. We just found the product of f of x and g. All right, so last one that I want to do is number 7. For number 7, we are asked to find, again, f of x times g of x. I'm going to write that out. F of x times g of x. It's really important that we keep everything lined up. All right? F of x times g of x. So, again, I have to know what f of x and g of x are. So, f of x, as it has been given, is x minus 13. And g of x is negative 5. All right, so what am I going to do? I'm going to plug these numbers in over here. So in place of f of x, I'm going to put in parentheses x minus 13. Just keeping everything aligned, keeping my structure the same so I don't lose anything. G of x is negative 5. So I'm going to put that in parentheses. So now, again, we are used to seeing a constant in front of the parentheses. So let's do that. It's kind of the coefficient of the parentheses. And so we want to move this negative 5 to the front. So let's do that. So let's take this negative 5. And remember, commutative property says that A times B is equal to B times A. So I can switch these two around and still get the same answer and not violate any properties. So I'm going to move this so that it says negative 5 times x minus 13. And again, it's still multiplication because a parenthesis next to each other, 2 parentheses next to each other means multiply. And I'm used to seeing it without the parentheses around the number out front. So I'm going to put negative 5 times x minus 13. Remember, you can manipulate it as long as there is a property or rule that allows you to do that. All right? And so in this case, it is commutative property. All right? So what are we going to do next? So we're going to distribute. And again, we're going to go ahead and use that mental math. We want to pay attention to, we want to be very precise and mind our structure. Okay, so we got negative times a positive. Negative times a positive is a negative. 5 times x is 5x. Do not drop your variable. It is part of your problem. All right. Now, I'm not going to just distribute to this first number. I'm going to distribute to both terms inside this parenthesis. So now, remember what I said to you before, we don't drop this minus just because it's there. This negative goes with this 13, and this negative goes with this 5. So what are we multiplying? Negative 5 times negative 13. A negative times a negative is a positive. That's where my sign is going to come from for my expression. So negative 5 times positive x is negative 5x, and negative 5 times negative 13 is positive 85. These two are unlike terms. They are not like. We cannot combine them. This is a variable term. This is a constant term. So therefore, it has been